Introducing GPT-4.1 in the API, a new series of GPT models featuring major improvements on coding, instruction following, and long context, plus our first ever nano model. Today, we're launching 3 new models in the API: GPT-4.1, GPT-4.1 Mini, and GPT-4.1 Nano. These models outperformed GPT-4o and GPT-4o Mini across the board, with major gains in coding and instruction following. They also have larger context windows, supporting up to 1 million tokens of context, and are able to better use that context with improved long context comprehension. They feature a refreshed knowledge cutoff of June 2024. GPT 4.1 excels at the following industry standard measures. Coding: GPT 4.1 scores 54.6% on SWE Bench Verified, improving by 21.4% ABS over GPT 4o and 26.6% ABS over GPT 4.5, making it a leading model for coding. Instruction following: on Scales Multi-Challenge, opens in a new window. Benchmark, a measure of instruction following ability. GPT 4.1 scores 38.3%, a 10.5% ABS increase over GPT 4o. Long context: on Video Me, opens in a new window, a benchmark for multimodal long context understanding. GPT 4.1 sets a new state-of-the-art result, scoring 72% on the long, no subtitles category, a 6.7% ABS improvement over GPT 4o. While benchmarks provide valuable insights, we train these models with a focus on real-world utility. Close collaboration and partnership with the developer community enabled us to optimize these models for the tasks that matter most to their applications. To this end, the GPT 4.1 model family offers exceptional performance at a lower cost. These models push performance forward at every point on the latency curve. GPT 4.1 Mini is a significant leap in small model performance, even beating GPT 4o in many benchmarks. It matches or exceeds GPT 4o in intelligence evals while reducing latency by nearly half and reducing cost by 83%. For tasks that demand low latency, GPT 4.1 Nano is our fastest and cheapest model available. It delivers exceptional performance at a small size with its 1 million token context window and scores 80.1% on MMLU, 50.3% on GPQA, and 9.8% on ADER polyglot coding, even higher than GPT 4o Mini. It's ideal for tasks like classification or auto-completion. These improvements in instruction, following reliability, and long context comprehension also make the GPT 4.1 models considerably more effective at powering agents, or systems that can independently accomplish tasks on behalf of users. When combined with primitives like the Responses API, opens in a new window, developers can now build agents that are more useful and reliable at real-world software engineering, extracting insights from large documents, resolving customer requests with minimal handholding, and other complex tasks. Note that GPT 4.1 will only be available via the API. In ChatGPT, many of the improvements in instruction following, coding, and intelligence have been gradually incorporated into the latest version. Opens in a new window of GPT 4o, and we will continue to incorporate more with future releases. We will also begin deprecating GPT 4.5 preview in the API, as GPT 4.1 offers improved or similar performance on many key capabilities at much lower cost and latency. GPT 4.5 preview will be turned off in 3 months on July 14, 2025, to allow time for developers to transition. GPT 4.5 was introduced as a research preview to explore and experiment with a large, compute-intensive model, and we've learned a lot from developer feedback. We'll continue to carry forward the creativity, writing quality, humor, and nuance you told us you appreciate in GPT 4.5 into future API models. Below, we break down how GPT 4.1 performs across several benchmarks, along with examples from alpha testers like Windsurf, Kodo, Hex, BlueJ, Thomson Reuters, and Carlyle that showcase how it performs in production on domain-specific tasks. Coding: GPT 4.1 is significantly better than GPT 4.0 at a variety of coding tasks, including agentically solving coding tasks, front-end coding, making fewer extraneous edits, following diff formats reliably, ensuring consistent tool usage, and more. On SWE Bench Verified, a measure of real-world software engineering skills, GPT 4.1 completes 54.6% of tasks, compared to 33.2% for GPT 4.0, November 20th, 2024. This reflects improvements in model ability to explore a code repository, finish a task, and produce code that both runs and passes tests. For SWE Bench Verified, a model is given a code repository and issue description and must generate a patch to solve the issue. Performance is highly dependent on the prompts and tools used. To aid in reproducing and contextualizing our results, we describe our setup for GPT 4.1 here. Opens in a new window. Our scores omit 23 of 500 problems whose solutions could not run on our infrastructure. If these are conservatively scored as 0, the 54.6% score becomes 52.1%. For API developers looking to edit large files, GPT 4.1 is much more reliable at code diffs across a range of formats. GPT 4.1 more than doubles GPT 4.0's score on Ader's polyglot diff benchmark, opens in a new window, and even beats GPT 4.5 by 8% abs. This evaluation is both a measure of coding capabilities across various programming languages and a measure of model ability to produce changes in whole and diff formats. We've specifically trained GPT 4.1 to follow diff formats more reliably, which allows developers to save both cost and latency by only having the model output change lines, rather than rewriting an entire file. For best code diff performance, please refer to our prompting guide, opens in a new window. For developers who prefer rewriting entire files, we've increased output token limits for GPT 4.1 to 32,768 tokens, up from 16,384 tokens for GPT 4.0. We also recommend using predicted outputs, opens in a new window, to reduce latency of full file rewrites. In Ader's polyglot benchmark, models solve coding exercises from exercism, opens in a new window, by editing source files with one retry allowed. The whole format requires the model to rewrite the entire file, which can be slow and costly. The diff format requires the model to write a series of search/replace blocks, opens in a new window. GPT 4.1 also substantially improves upon GPT 4.0 in front-end coding and is capable of creating web apps that are more functional and aesthetically pleasing. In our head-to-head comparisons, paid human graders preferred GPT 4.1's websites over GPT 4.0's 80% of the time. Beyond the benchmarks above, GPT 4.1 is better at following formats more reliably and makes extraneous edits less frequently. In our internal evals, extraneous edits on code dropped from 9% with GPT 4.0 to 2% with GPT 4.1. Windsurf opens in a new window. GPT 4.1 scores 60% higher than GPT 4.0 on Windsurf's internal coding benchmark, which correlates strongly with how often code changes are accepted on the first review. Their users noted that it was 30% more efficient in tool calling and about 50% less likely to repeat unnecessary edits or read code in overly narrow, incremental steps. These improvements translate into faster iteration and smoother workflows for engineering teams. Codo opens in a new window. Codo tested GPT 4.1 head-to-head against other leading models on generating high-quality code reviews from GitHub pull requests using a methodology inspired by their fine-tuning benchmark. Across 200 meaningful real-world pull requests with the same prompts and conditions, they found that GPT 4.1 produced the better suggestion in 55% of cases. Opens in a new window. Notably, they found that GPT 4.1 excels at both precision, knowing when not to make suggestions, and comprehensiveness, providing thorough analysis when warranted, while maintaining focus on truly critical issues. Instruction following. GPT 4.1 follows instructions more reliably and we've measured significant improvements across a variety of instruction following evals. We developed an internal eval for instruction following to track model performance across a number of dimensions and in several key categories of instruction following, including format following, providing instructions that specify a custom format for the model's response, such as XML, YAML, Markdown, etc. Negative instructions, specifying behavior the model should avoid. Example, don't ask the user to contact support. Ordered instructions, providing a set of instructions the model must follow in a given order. Example, first ask for the user's name, then ask for their email. Content requirements, outputting content that includes certain information. Example, always include amount of protein when writing a nutrition plan. Ranking, ordering the output in a particular way. Example, sort the response by population count. Overconfidence, instructing the model to say, I don't know, or similar if requested information isn't available, or the request doesn't fall in a given category. Example, if you do not know the answer, provide the support contact email. These categories are the result of feedback from developers regarding which facets of instruction following are most relevant and important to them. Within each category, we've split up easy, medium, and hard prompts. GPT 4.1 improves significantly over GPT 4.0 on hard prompts in particular. Our internal instruction following eval is based on real developer use cases and feedback, covering tasks of varying complexity coupled with instructions on formatting, verbosity, length, and more. Multi-turn instruction following is critical for many developers. It's important for the model to maintain coherence deep into a conversation and keep track of what the user told it earlier. We've trained GPT 4.1 to be better able to pick out information from past messages in the conversation, allowing for more natural conversations. The multi-challenge benchmark from Scale is a useful measure of this capability, and GPT 4.1 performs 10.5% abs better than GPT 4.0. In multi-challenge, opens in a new window. Models are challenged on multi-turn conversations to properly use 4 types of information from previous messages. GPT 4.1 also scores 87.4% on IF eval, compared to 81% for GPT 4.0. IF eval uses prompts with verifiable instructions, for example, specifying content length or avoiding certain terms or formats. Better instruction following makes existing applications more reliable and enables new applications previously limited by poor reliability. Early testers noted that GPT 4.1 can be more literal, so we recommend being explicit and specific in prompts. For more on prompting best practices for GPT 4.1, please refer to the prompting guide. Real-world examples. BlueJ opens in a new window. GPT 4.1 was 53% more accurate than GPT 4.0 on an internal benchmark of BlueJ's most challenging real-world task scenarios. This jump in accuracy, key to both system performance and user satisfaction, highlights GPT 4.1's improved comprehension of complex regulations and its ability to follow nuanced instructions over long contexts. For BlueJ users, that means faster, more reliable tax research, and more time for high-value advisory work. Hex opens in a new window. GPT 4.1 delivered a nearly 2 times improvement on Hex's most challenging SQL evaluation set. Opens in a new window, showcasing significant gains in instruction following and semantic understanding. The model was more reliable in selecting the correct tables from large, ambiguous schemas, an upstream decision point that directly impacts overall accuracy and is difficult to tune through prompting alone. For Hex, this resulted in a measurable reduction in manual debugging and a faster path to production-grade workflows. Long context. GPT 4.1, GPT 4.1 Mini, and GPT 4.1 Nano can process up to 1 million tokens of context, up from 128,000 for previous GPT 4.0 models. 1 million tokens is more than 8 copies of the entire React codebase. So long context is a great fit for processing large code bases or lots of long documents. We trained GPT 4.1 to reliably attend to information across the full 1 million context length. We've also trained it to be far more reliable than GPT 4.0 at noticing relevant text and ignoring distractors across long and short context lengths. Long context understanding is a critical capability for applications across legal, coding, customer support, and many other domains. Below, we demonstrate GPT 4.1's ability to retrieve a small hidden piece of information, a needle, positioned at various points within the context window. GPT 4.1 consistently retrieves the needle accurately at all positions and all context lengths, all the way up to 1 million tokens. It is effectively able to pull out relevant details for the task at hand regardless of their position in the input. In our internal needle in a haystack eval, GPT 4.1, GPT 4.1 Mini, and GPT 4.1 Nano are all able to retrieve the needle at all positions in the context up to 1M. However, few real-world tasks are as straightforward as retrieving a single, obvious needle answer. We find users often need our models to retrieve and understand multiple pieces of information and to understand those pieces in relation to each other. To showcase this capability, we're open sourcing a new eval, OpenMRCR, multi-round coreference. OpenMRCR tests the model's ability to find and disambiguate between multiple needles while hidden in context. The evaluation consists of multi-turn synthetic conversations between a user and assistant where the user asks for a piece of writing about a topic, for example, write a poem about tapers or write a blog post about rocks. We then insert 2, 4, or 8 identical requests throughout the context. The model must then retrieve the response corresponding to a specific instance, e.g., give me the third poem about tapers. The challenge arises from a similarity between these requests and the rest of the context. Models can easily be misled by subtle differences, such as a short story about tapers rather than a poem, or a poem about frogs instead of tapers. We find that GPT 4.1 outperforms GPT 4.0 at context lengths up to 128K tokens and maintains strong performance even up to 1 million tokens. But the task remains hard, even for advanced reasoning models. We're sharing the eval dataset, opens in a new window, to encourage further work on real-world long context retrieval. In OpenMRCR, opens in a new window. The model must answer a question that involves disambiguating between 2, 4, or 8 user prompts scattered amongst distractors. We're also releasing graph walks, opens in a new window, a dataset for evaluating multi-hop long context reasoning. Many developer use cases for long context require multiple logical hops within the context, like jumping between multiple files when writing code or cross-referencing documents when answering complicated legal questions. A model, or even a human, could theoretically solve an OpenMRCR problem by doing one pass or read-through of the prompt. But GraphWalks is designed to require reasoning across multiple positions in the context and cannot be solved sequentially. GraphWalks fills the context window with a directed graph composed of hexadecimal hashes, and then asks the model to perform a breadth-first search, BFS, starting from a random node in the graph. We then ask it to return all nodes at a certain depth. GPT 4.1 achieves 61.7% accuracy on this benchmark, matching the performance of O1 and beating GPT 4.0 handily. In GraphWalks, opens in a new window. A model is asked to perform a breadth-first search from a random node in a large graph. Benchmarks don't tell the full story, so we worked with alpha partners to test the performance of GPT 4.1 on their real-world long context tasks. Real-world examples. Thomson Reuters opens in a new window. Thomson Reuters tested GPT 4.1 with CoCounsel, their professional-grade AI assistant for legal work. Compared to GPT 4.0, they were able to improve multi-document review accuracy by 17% when using GPT 4.1 across internal long-context benchmarks, an essential measure of CoCounsel's ability to handle complex legal workflows involving multiple, lengthy documents. In particular, They found the model to be highly reliable at maintaining context across sources and accurately identifying nuanced relationships between documents, such as conflicting clauses or additional supplementary context, tasks critical to legal analysis and decision-making. Carlyle opens in a new window. Carlyle used GPT 4.1 to accurately extract granular financial data across multiple, lengthy documents, including PDFs, Excel files, and other complex formats. Based on their internal evaluations, it performed 50% better on retrieval from very large documents with dense data and was the first model to successfully overcome key limitations seen with other available models, including needle-in-the-haystack retrieval, lost-in-the-middle errors, and multi-hop reasoning across documents. In addition to model performance and accuracy, developers also need models that respond quickly to keep up with and meet users' needs. We've improved our inference stack to reduce the time to first token, and with prompt caching, you can cut latency even further while saving on costs. In our initial testing, the P95 latency to first token for GPT 4.1 is approximately 15 seconds with 128,000 tokens of context, and up to half a minute for 1 million tokens of context. GPT 4.1 Mini and Nano are faster, e.g., GPT 4.1 Nano most often returns the first token in less than 5 seconds for queries with 128,000 input tokens. Vision. The GPT 4.1 family is exceptionally strong at image understanding, with GPT 4.1 Mini in particular representing a significant leap forward, often beating GPT 4.0 on image benchmarks. In MMU, opens in a new window. A model answers questions containing charts, diagrams, maps, etc. Note: even when the image is not included, many answers can still be inferred or guessed from context. In Math Vista, opens in a new window. A model solves visual mathematical tasks. In Char 14 Reasoning, opens in a new window. A model answers questions about charts from scientific papers. Long context performance is also important for multimodal use cases, such as processing long videos. In Video MME, opens in a new window. Long without subs, a model answers multiple choice questions based on 30 to 60-minute long videos with no subtitles. GPT 4.1 achieves state-of-the-art performance, scoring 72%, up from 65.3% for GPT 4.0. In Video MME, opens in a new window. A model answers multiple choice questions based on 30 to 60-minute long videos with no subtitles. Pricing. GPT 4.1, GPT 4.1 Mini, and GPT 4.1 Nano are available now to all developers. Through efficiency improvements to our inference systems, we've been able to offer lower prices on the GPT 4.1 series. GPT 4.1 is 26% less expensive than GPT 4.0 for median queries, and GPT 4.1 Nano is our cheapest and fastest model ever. For queries that repeatedly pass the same context, we are increasing the prompt caching discount to 75%, up from 50% previously, for these new models. Finally, we offer long context requests at no additional cost beyond the standard per token costs. Conclusion. GPT 4.1 is a significant step forward in the practical application of AI. By focusing closely on real-world developer needs, ranging from coding to instruction following and long context understanding, these models unlock new possibilities for building intelligent systems and sophisticated agentic applications. We're continually inspired by the developer community's creativity and are excited to see what you build with GPT 4.1. Appendix. A full list of results across academic, coding, instruction following, long context, vision, and function calling evals can be found below.